A truck caught fire in Houston. Firefighters arrived and used water. But this was not an ordinary fire. When water hit the burning material, the fire reacted violently. What followed was an intense metal fire, a dangerous fireball, and a reminder that some industrial materials can become deadly when handled the wrong way. At 4:20 p.m. on March 2nd, 2026, Houston's emergency dispatchers received a call from a scrapyard on Lockwood Drive. Smoke was rising from a parked truck, and the 911 operator assigned the incident as a standard vehicle fire. Within minutes, the first Houston Fire Department engine rolled through the yard's iron gates, its crew already suited up and ready for what looked like a routine call. Helmet cam footage later confirmed the arrival. Orange flames licking the cargo area, and white smoke curling above the drums stacked on the trailer. The scrapyard, operated by Scorpion's Metal, was busy with workers and machinery. As the fire engine stopped, the crew immediately began their size up. The incident commander, Captain Luis Mendoza, gave a hand signal to advance the hose. At the same moment, a Sky I-13 helicopter circled above, streaming live video to local newsrooms. The aerial feed captured the fire's early stages. Flames confined to one end of the trailer. No visible spread to nearby buildings, and no sign yet of anything unusual in the cargo. Houston Police Department's Environmental Investigation Squad arrived at the perimeter, joining the growing crowd of responders. Their presence hinted at possible hazardous material concerns, but at that point, no one on scene had identified the truck's load as anything other than scrap. Firefighters unreeled a 2-inch hose and prepared for a direct water attack, the standard tactic for vehicle and debris fires. The incident commander's radio call, "Apply water now," was picked up on dispatch audio. A solid stream of water hit the flames, sending up a hiss and a cloud of steam. At street level, the operation looked methodical and controlled. Aerial footage from Sky I-13 showed a cluster of engines, police cruisers, and a medic unit forming a cordon around the yard. The sense among crews was that this was a straightforward response, with no indication yet of the chemical hazard inside the cargo. The critical detail, the true nature of the material burning inside those drums, remained hidden, setting the stage for what would become a far more dangerous situation. The drums on the truck looked unremarkable. Standard 55-gallon steel barrels, sealed tight, with their surfaces dulled by years of handling. No warning placards, no hazard diamonds, nothing to suggest that what lay inside could turn a routine fire into a chemical disaster. Firefighters on scene saw only generic shipping labels, the kind used for scrap metal or industrial waste. In the chaos of a busy yard, these containers blended in with the landscape of discarded machinery and metal offcuts. Inside those drums, however, was something far more volatile than ordinary scrap. The cargo consisted of magnesium shavings, a byproduct from machining and grinding operations in the automotive and aerospace industries. These shavings, often swept up from factory floors, are collected in bulk and sold as salvage. Their appearance, gray, flaky, sometimes powdery, offers no obvious clues about their chemical reactivity. Unlike solid blocks of metal, shavings have a dramatically larger surface area exposed to air. This makes them far more likely to ignite and burn at extreme temperatures. Scrapyards across Texas receive shipments like this every week, often without detailed manifests or proper hazardous material documentation. In this case, the drums arrived at Scorpion's Metal with only generic paperwork and internal markings, not the federally required Class 4.1 placards for combustible metals. The lack of clear labeling meant that neither the yard staff nor the first arriving fire crew had any reason to suspect a reactive metal fire. Standard operating procedure called for a direct water attack, a tactic that works for most debris or vehicle fires but can be catastrophic when magnesium is involved. The practice of sealing shavings in steel drums is meant to contain dust and prevent accidental ignition during transport. But these same drums, when unmarked, can conceal the true hazard from anyone who handles them. Without external warnings, the line between ordinary waste and a chemical time bomb becomes dangerously thin. The responders, trained to assess risk by what they can see and read, were left in the dark about the material's true nature. As water hit the flames, the hidden danger inside those drums was about to be revealed. Magnesium shavings, unlike solid chunks of metal, present a challenge that goes far beyond ordinary fire behavior. The key lies in their surface area. When magnesium is shaved or ground into fine fragments, every flake exposes a fresh metallic face to air, multiplying the sites where combustion can begin. Laboratory studies show that as particle size drops below 100 microns, the minimum ignition temperature can fall to just over 400 degrees Celsius, far lower than what is needed to ignite a solid bar. Once burning starts, the reaction is fierce. Magnesium combines with oxygen to form magnesium oxide, releasing about 601 kilojoules per mole. This energy drives flame temperatures above 2,500 degrees Celsius, hot enough to melt steel and to project burning fragments several meters from the source. The danger escalates when water enters the equation. At these extreme temperatures, water does not suppress the fire. Instead, it reacts directly with the hot magnesium, splitting into hydrogen gas and magnesium hydroxide. The chemical reaction, magnesium plus 2 molecules of water, produces magnesium hydroxide and hydrogen gas, and releases additional heat, not just steam. Each kilogram of magnesium shavings can produce nearly a cubic meter of hydrogen when exposed to water. That hydrogen, surrounded by an already blazing fire, can ignite instantly, fueling a rapid pressure spike and expanding the fireball in a confined space like a steel drum. The more finely divided the magnesium, the faster and more violently this reaction unfolds. Once water is applied to burning shavings, the chain of events, heat, hydrogen, and explosive combustion becomes nearly impossible to stop with conventional tactics. The chemistry leaves little room for error, and what starts as a manageable blaze can escalate into a catastrophic event in seconds. Captain Luis Mendoza gave the water order less than a minute after stepping onto the scene. His voice came through clearly on the radio. "Apply water now." The crew followed standard operating procedure for a truck or debris fire, advancing the hose and directing a solid stream at the base of the flames. The decision happened fast. There was no time to consult hazardous material manifests, and nothing in the yard's paperwork or drum labeling hinted at a special risk. In the absence of warning placards, the call to use water was textbook, a move any incident commander would make under the circumstances. The initial spray brought a hiss and a surge of white steam, but the fire didn't recede. Instead, a violent reaction began almost immediately. Within seconds, a white-blue flash erupted from the cargo area, followed by a burst of pressure and a fireball that expanded outward. The radio captured the chaos, shouts for backup, rapid calls for medical aid, and the realization, too late, that this was not a typical fire. The tactical choice to use water, made in the absence of clear hazard identification, set off a chain reaction that would define the rest of the incident. The lack of external warnings on the drums and incomplete documentation meant that the command team was working blind, forced to rely on assumptions that proved catastrophically wrong. The consequences of that split-second decision would be measured in injuries, trauma, and a hard lesson about the dangers hidden inside unmarked steel barrels. 4 people suffered severe burns in the seconds after the fireball erupted from the truck's cargo. 2 workers caught just meters from the blast received second-degree burns to their arms and faces. A firefighter on the hose line was thrown back by the pressure wave, his turnout gear scorched through to the skin. Another responder, attempting to pull a co-worker clear of the hazard zone, sustained burns to his hands and neck. Hospital records confirmed that all 4 were treated for thermal trauma and blast injuries, with 2 admitted to the intensive care unit for airway monitoring and wound care. The physical pain was immediate, but so was the confusion. No one on scene had expected a standard water attack to trigger such violence. The crew's first engine had arrived with every tool for a routine fire, but not the one thing that could have made a difference: a Class D extinguishing agent. Inventory logs later reviewed by investigators showed that Engine 1 carried no magnesium-rated dry powder, only standard ABC extinguishers and water-based suppression gear. The nearest Class D agent was stocked on a hazmat truck stationed across town, unreachable in the critical first minutes. In interviews, firefighters described the helplessness of watching the fire intensify with every attempt to control it. They relied on water because it was what they had, not because it was right for the material burning in front of them. The consequences went beyond the immediate injuries. The lack of specialized suppression media turned a survivable fire into a mass casualty event. For those caught in the explosion, the scars, both physical and psychological, would last far longer than the smoke that drifted over 2nd Ward that afternoon. The absence of proper labeling and the missing Class D agent exposed a gap in the city's emergency response, one that would be scrutinized by investigators and families alike. Today, misidentified cargo and routine assumptions still move through busy cities. Magnesium in fine form remains a silent risk. Water can make it explosive, releasing hydrogen and fire, until every link in the chain takes hazardous materials seriously. The next disaster isn't just possible, it's inevitable. Stay vigilant out there.